Hello everybody, in this video we are going to talk about the tangent and secant segments of a circle. So let's start off by talking about what is a tangent segment, what is a secant segment, what is an external segment. We're going to identify these and know where they're located on a circle. And then we're going to look at two theorems that are associated with segments of secants and segments of a secant and a tangent. And we'll solve some problems using those theorems. So we start off here and we have a tangent segment is just a segment that is tangent to a circle at an endpoint. So here we have our tangent segment is written in white, and we have our tangent segment right here in white as well. So that would be segment AD. So remember, a tangent segment just is a segment that intersects, or a tangent line would be a line that intersects a circle in one point, and that's what we see here. Next we have a secant segment, and that is a segment that contains a chord of the circle and has exactly one endpoint outside the circle. Let's go ahead and talk about external segment before we look at our diagram. External segment is part of the secant segment, but it's the part that is outside the circle. So I have the external segment in pink here, and I have our secant segment in a navy blue. So if we look at our diagram, our entire secant segment is AC, but then part of that is outside is AB, and we call that the external segment of our secant segment. Okay, so let's look at our first theorem. And it is called the segments of secants theorem. And it states that if two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So really wordy there, I know, but let's look at our diagram and look at our equation that we can form over here. So we have two secants, AC and AE. And what we're going to do is we're going to take the product of the external segment. So if we look here at this first secant segment, that's going to give us this part of our equation. So we're going to say AB, which is its external segment, times AC, which is the entire secant segment. And we're going to set that equal to the external segment, so AD, times the entire secant segment of our other secant segment, which is AE. Okay, so let's look at an example where we use this theorem. All right, so we want to find the value of x. And so we have our external segments 3 and 4, and then our entire secant segment, we can see that as well. So for this secant segment, we are going to say 3 times, so 3 is our external segment, and then we're going to do 3 plus 9. Okay, so now I know that's 12. We're going to simplify that in just a minute, but I wanted us I wanted to write it that way so that we can see we are adding those two segments together to get our entire secant segment length. Okay. Now we are going to set that equal to 4 times 4 plus x, okay? All right, so now we can just solve this. So like we said a minute ago, 3 plus 9 is 12. And here we can distribute this 4 to get 16 plus 4x. And we know that 3 times 12 is 36. So now we have 36 is equal to 16 plus 4x. And now we can just solve this two-step equation by subtracting 16. So we get 20 equals 4x, and we can divide both sides by 4, and we get x is equal to 5. Okay, so that is the segments of secants theorem. Okay, now let's talk about segments of secants and tangents theorem. Very similar, but subtle differences, so let's pay attention. If a secant segment and a tangent segment share the same endpoint outside a circle, so here we go, then the product of the lengths of the secant segment and its external segment, so similar to what we just looked at, but now it's equal to the square of the length of the tangent segment. So here our tangent segment is AB, so notice we have AB squared because that's the square of the tangent segment. And now it's equal to, and very similar to what we just looked at in the segments of secants theorem, AC times AD. Okay, so AC would be our external segment, and then we have AD, which is our entire secant segment. Okay, so let's look at a couple examples where we use this theorem. All right, so for both of these, we just want to find the value of x. So for number 1, we have our tangent segment here is x, so we can say x squared is equal to, and now we're going to multiply 12 times, and we're going to add these two together. So 12 plus 15. So here we get x squared equals 12 times 27. And 12 times 27 is 324. And now we can take the square root of both sides. So now we introduced the square root, so technically our answers are positive and negative 18. However, we are finding a length here, so we're only going to take the positive value. So here, x is equal to 18, okay? All right. Number 2, we have a diameter that is going through the middle of our circle, and we've kind of split that up into the 2 radii, okay? So x is equal to the radius here. So essentially that's what we're finding, what's the radius of this circle. So we have our tangent segment here, so we can say 3 squared is equal to, and now we're going to multiply 1, because that's our external segment, times, and we're going to do x plus 1, because that would be our entire secant segment, right? It's kind of split up into 3 pieces there. So now 3 squared is 9. 1 times anything is still going to be the same thing, so we can just focus on what's in parentheses here. X plus x is 2x, and we have this plus 1. Now we can just solve this 2-step equation by subtracting 1, and now let's divide both sides by 2, and we get x is equal to 4. Okay, so that is how we handle some segments that are some secant and tangent segments of circles.